So hello guys, we are dealing with a very simple yet difficult problem of Newton's law. We have a chain of mass m which is hanging between two fixed support A and B, and we have to find out the tension at the point A and B and the midpoint of the chain. If you want to give this problem a try, you can pause the video and then continue watching for the solution. So let us deal with the solution of this problem. Before we start solving this problem, let us deal with one small problem. So over here, if I consider that there are two boys, A and B, and they are trying to play tug of war using a string. If this boy is exerting a force of 50 Newton towards the left, and the another boy is exerting a force of 50 Newton towards the right, then what is the tension in the string? So the most common mistake which people make is they either answer the force to be 0 or they answer it to be 100 Newton. So let us find out the correct answer for this particular aspect, and then we will try to understand this particular problem. So over here, if we consider this situation, then we can definitely say that according to the situation which we have, there is no net force in the x direction, and therefore acceleration in the x direction is 0. So if acceleration in the x direction is 0, and if I draw FBD of one of the boy, so if we draw FBD of one of the boy, then we can say that if there is a force of 50 Newton exerted in this direction, and there is a rope like this, then for net force to be 0 in this FBD, the tension in the spring, which is T, so T minus 50 must be 0. So tension in the string is 50 Newton. So at any point in this rope, the tension must be 50 Newton for the system to be in equilibrium. Otherwise, the system will not stay in equilibrium. Now, if we look at this particular scenario, so over here we can say that at point A and B, the tension which is going to act is TA and TB respectively. So we have TA and TB respectively. What is important for us to understand is that the entire system is in equilibrium, that the chain is hanging at rest between these two fixed support at point A and B. So over here, if we take the component of tension and force, so this angle is also theta, then we can say that this component is TA cos theta, and the component above is TA sin theta. And over here, similarly, we can say that this component is TB cos theta, and this component is TB sin theta. So over here, if we apply the equation that there is no net force in the x direction, so net force in the x direction is 0. So over here, we can say TA cos theta towards left and TB cos theta towards right must sum together to become 0. So from here it is clear that tension at point A is equal to tension at point B, that is T. We can also directly say that tension at both point A and B will be same because the diagram is symmetric in nature. But if we want to establish that the two tensions are equal, then we can definitely use this equation and establish that tension at both points A and B are same. Now, the next equation which we write is along y-axis. So net force in the y-axis is also 0. So over here, we can say that the force in the upward direction 2TA sin theta, or we can simply write 2t sin theta. So we are trying to write TA sin theta plus TB sin theta, or since TA equal to TB equal to T, we can write 2t sin theta is equal to the weight mg in the downward direction, and hence when we calculate this t, we get mg by 2 sin theta, or we can simply write half mg cosec theta. So this is the first part of the problem which we have. Now, in the second part of the problem is asking us the tension in the midpoint of the chain. So over here, in the midpoint of the chain, if we are going to calculate the tensional force, so if I remove this layer of the chain, or if I say that if we are drawing two different MPDs, the chain on the left hand side and the chain on the right hand side, so over here, we say that if this tension is T naught and the tension on the left hand side is equal to T naught, so for this system to be in equilibrium, it is just like this particular problem, that at both ends, the tension exerted is TA cos theta, TB cos theta, which is established to be equal to each other, that is TV cos theta is equal to TA cos theta. So therefore, from this particular analogy, we can say that TA cos theta must be equal to T naught, which is equal to TB cos theta. And since TA and TB are same, so we can say T naught is equal to T cos theta. If we substitute the value of T from here, we get mg by 2 cos theta by sin theta, that is cot theta. So from here, we have solved both the parts, point A and B, and midpoint of the chain. So to brief this problem once again, we started from this particular problem, which is an easier version. If we understand this, then only can we solve the last part of the problem. Otherwise, we'll again make this mistake of writing the value of tension to be equal to 0 at this particular point. So over here, we have dealt with a simple problem of statics, where we have discussed the tension in the chain at the end points and in the middle of the chain. I hope you like this video. Please continue watching, like, share and subscribe. Continue to learn and grow.